Okay. Okay, so. Technical issue, sorry. Okay, so here we go. Right, so I'd like to start off, I'll tell you a little bit about where I've come. So I work for a company called Find My Past, and what we do is help people trace their family history through usage of things like family trees and historical records. But I've had a bit of an interesting career through the years, and I started off right at the very beginning as a QA in games. So I tested PlayStation games for 8 hours a day for about 3 months to begin with. And what was interesting about that was we would all turn up at 9 a.m., team of 10 of us, and then we would wait around until 10, until the disks burnt off because the machine took a little while. And that stayed the same for the whole time that I was there, but no one ever, fixed that. And then later on, I was moved into design and then C++ engineer. And in that job, there was a huge amount of merging of code. So we had this really interesting branching strategy where I'd have my own branch and then a team branch and then the master branch, but we were all siloed. And I spent 5 days a month integrating code. And yeah, that was never fixed in the 4 years I was there. And that kind of takes me on to why I love DevOps, is, it's all about moving the chair. It's all about, moving the table in this case so I can walk over there. And that for me is why I love it. It's, you can get into this situation where, you can come in on a Monday, you can develop a feature, and you can get that out in front of customers, and you can get that feedback. And when I've seen that possible, developers just get so engaged. And that's why I think it's great. So, a little intro. I'd like to start off with a little analogy about my family. So, I got married about 5 years ago into a pretty big Irish family. So my wife has 5 sisters and 1 brother. They've had 20 children between them. And from that, there's now 6 more children from those children. So ever growing. And from my side of the family, it's pretty tiny. But if you think about the nature of all those relationships with the people, it's really complex. You've got to understand all that. And you've also got to understand how people are interacting. You've got to learn everyone's names. So I've only just managed that, 10 years on. and that kind of makes me think about us as a business. So, you're looking to find product market fit with a product, and you take on technical debt. And for us, it was all about this big monolith and a database. But I'd like to do a quick survey of everyone first. So who here has worked with a database with a single application talking to it, so a one-to-one relationship? Okay, so that's everyone, just about. Who here has worked with a database with 2 applications? 3 applications? 4 applications? 5? Okay, so getting less. 6? Right, those with 6, they get beer, because that's hard. So we were in the situation of our kind of main application, main database, and 4 other applications. And it was, and what this story is all about is a journey about reducing complexity, about being able to deliver faster, and getting to this place where people can get engaged and they can deliver on a weekly basis. So, I'd like to credit my daughter, you probably saw her up there, because I get to read a lot of technical books, but I read a lot of children's books now as well. And yeah, she gave me the idea for this book, so thanks very much. In the light of the moon, a little egg lay on a leaf. One Sunday morning, the warm sun came up, and out of the egg came a tiny and very hungry caterpillar. So, meet the caterpillar. He's our hero of the story. But first of all, we've got to introduce the villain. Our villain here is complexity. So our monolith was about 150,000 lines of code, and it was just like this, big pile of spaghetti. And, our little caterpillar's thinking to himself, how do I even begin sorting this out? We decided as a company that we wanted to really address some of these underlying problems that we have. So our little caterpillar thought to himself, what's at the core of all of this? Well, it's the user account. The users come to the site. And it was pervasive throughout the entire code base, all the way from the view right down to the database and stored procedures. And we couldn't make changes to it. The little caterpillar was given a task before that, and it took him 3 months to make a really simple change to our payment system. And that had to be sorted out. If we were to survive as a business, I would say that definitely had to be sorted out. So we've picked account, and our little caterpillar is going to start pulling on that thread. So on Monday, he ate a gherkin, but he was still hungry. And where did he start? So our little caterpillar got chatting to the product owner and thought, we really have to document all the functionality of account. Not just in a unit test way, but in a behavioral way. So that was the first thing. So it was about describing all of the account functionality, things like registrations, logins, get by ID, get by email, and the various different functionalities that we require for account. And that was going great. The second thing to chat about here is the 3 ways of DevOps. So we came up against the first way of DevOps, the flow. And in our monolith, when I joined the company, it took about 4 days to release. It was a big manual QA process. And we worked slowly towards something better over the course of 4 years. And it was about an hour when this team started on the project. So our little caterpillar identified this as a constraint, and we removed some of the contention in the build pipeline, removed some of the duplicated logic, and got that down from a flaky 1 hour to a pretty reliable 35 minutes. And that was a really big step in the right direction of being able to make changes to the monolith in a safe way. So this is the architecture that we had at the time. So you can see there's a couple of apps on the left talking to the same database as the monolith. So the first thing was creating an account-bounded context and an API, and then exercising that from the outside in with this set of tests. And then switching over the apps to using the API, and then that way we had an isolated database and we could move on. But this wasn't without issue. So the first thing was about emails. During this phase, we caused quite a lot of problems with what they called transactional emails. You get a lot of transactional emails. When you're working with something like account, you need to send emails to customers to let them know that they're making changes to their account. And it's something that we've still not cracked. We still don't have a full end-to-end automated test that checks the transactional emails that go out. And that's something that we're looking at. Next thing to chat about is to move your boulders. At the beginning of this project, we could definitely have looked at the deployment pipeline, and we could have extrapolated out how much time we were going to spend if we were going to deploy every day for 6 months, or twice a day, or 3 times a day. You want that lower batch size. And I feel like that's something that we've definitely learned from here, is to identify bottlenecks to your delivery right at the very beginning of projects. And if you need to do some remedial work at the beginning, you should do it, because it will pay off more. So we have a happy caterpillar. On Tuesday, he drank an elixir, but he was still hungry. Why elixir, you might ask? So we started off with elixir, and we did a spike. And we replicated an existing API that we have. And then we load tested it. And a couple of things that we noticed. It was, we got about twice the throughput on about half the hardware. And it didn't take very long to write. It was only about 50% of the lines of code of our existing API. It wasn't a very big one, but it gave us enough confidence that we thought, yeah, we'll give it a try for 6 months and then see where we're at and see if we like Elixir. So Elixir is built on the Erlang VM. I don't know, just to give you guys a bit of background to that. And what were the benefits of this? So we built an account proxy to begin with, and we were able to adopt continuous deployment and trunk-based development, which we weren't able to do on the monolith, not at that time. So this is the architecture that we've got. And then we put in place this account proxy. So the account proxy mirrors the API that's on the monolith, and you can exercise that with the Gherkin test and see that everything still passes. So that's great. And then you can point your other applications at it. So there's a few things that we learned here, though. First of all, we didn't integrate as soon as we could have. We could have gone one route at a time, but we mirrored the entire API. And inevitably, when you put a new piece of functionality into production, you're going to get some unplanned work from that integration. So we could have found that sooner, and we could have shortcutted it and maybe done things a bit faster. So that was what we learned there. And we've got a happier caterpillar. Things are getting simpler. On Wednesday, he met a canary, but he was still hungry. Our little canary here is our second hero. He taught the caterpillar some patterns. He taught him about canary releasing. He taught him about circuit breakers. He taught him about retries. So here, we've got our little, it's now becoming an account service. So we're building out the logic, and we're replicating what is in the monolith in the account bounded context. And slowly but surely, you can switch the traffic over. But what you do is you do it with the canary. So this was fine for us. We did it with static config in the account service, and our little caterpillar was getting happier. And eventually, it took some time, but we managed to get 100% of the traffic across through using canary releasing. But that left it in a bit of a dangerous situation. You've got two copies of the business logic. And if you have any divergence, that's going to cause serious problems in the database. So as quickly as possible, we went to move all of the account traffic to be using the account service outside of that. So here was where we brought in place the circuit breakers, or we really, really saw the benefit of them. In the account-bounded context, it would call out to the account service. And in a certain amount of failures, what it would do is fail over and then just use the logic within the monolith. And that saved our bacon quite a few times. As you add more and more traffic to something else, you start finding integration problems. And that was really great because we didn't see any service outages at this point. Until finally, we got to 100% going through the account service, and the logic in the monolith was no longer being used. So we've got a happier caterpillar. And what did we learn during this point? So we didn't learn our lesson about constraints beforehand. In the account, we were still bound by the 35 minutes it took to release the monolith, and we were doing that with static config. What we did to make that easier was we put in place a third party called Launch Darkly, which was a feature toggling thing. And that gave us a slider that we could do the traffic. So it went from a 35-minute deployment to an instant change to the amount of traffic that was either being serviced by the account in the monolith or the account service outside of that. So that was really, really useful in terms of being able to remediate any issues that were happening. And yeah, happy caterpillar, happy canary. So on Thursday, our little caterpillar, he analyzed 4 graphs, but he was still confused. This is about the second way of DevOps, about feedback. So this is about us building dashboards. And this is what one of our dashboards looks like. So we've got up at the top, we've got request time. So we can see the health of the service as more and more traffic is going through it. You can see whether it's performing as you would expect or if it's getting worse. You can see the errors as well and the total number of requests that are being served. So this was really useful to us. And we try and build all our dashboards with something in mind. It's all about, can you tell within a couple of seconds are you winning or are you losing? The point of a dashboard is to give you feedback, but so that you can make a decision as to what you might do if something was going to go wrong. If you start getting an error spike, you want to pull that canary right back, and you want to do it as quickly as possible. And you need that instantaneous feedback, and that was something that we really, really adopted. Okay. On Friday, he had an outage due to a broken contract, so he called in the jackal. So, failure is inevitable. We found that out over the course of this. And one of the things that happened was we made a small change to the account service, and it changed the shape of the data of one of the responses. And that caused multiple upstream failures, and it was actually quite difficult to debug and figure out what was going wrong. So in the postmortem, we figured out that something that we could try was consumer-driven contracts. So, what are consumer-driven contracts? On our right, we've got our consumers of the account service. And in each of these code bases is a set of contracts that they require of the account service to fulfill. When these guys deploy, what they do is they submit their contracts to the centralized contract service called Jackal. And this is just one implementation of consumer-driven contracts. There's multiple ways you can do this. And then finally, we've got the account service. So when account deploys itself, it spins a container up. And it's up there. And then it takes the URL, and it sends it over to Jackal, and it says, exercise all the contracts you have against me, and tell me if I'm going to break any of my upstream consumers. So that was really, really useful for us. That was an open source project. You can find that on NPM. Last month, it ran 35,000 tests, and it caught 7 failures. And what did we learn here? We learned a lot about upstream resiliency, making sure that we've got proper failover with circuit breakers, retries, and really good logging and monitoring to see if we're making mistakes or not. And that's something that we're working towards. And the other thing that we learned here was maybe to spend a bit longer at the beginning stage. So we missed a vital requirement when we were building Jackal, which was idempotent tests. The test would pass the first time, but not the second time. And what we want is that test to be runnable continuously. So that was something that we missed and caused an extra week of work. So yeah, just make sure you're chatting to all your customers and you're getting the requirements. So on Saturday, he met a kind shepherd who guided him home. So we're getting towards the end of our story now. And our shepherd is who helped migrate the database. So we've got our account service, and we've got our old database, which is the monolith database. We've got our new database. We were migrating from Microsoft SQL to Postgres. And then finally, in comes Shepherd. And what Shepherd did was it did the initial migration from the old database to the new database. But then after that, it also monitored the divergence of the databases. So the account service was writing and reading to both, but it was throwing away the reads from the new database. And we were logging information about how much the two databases were diverging. And that told us whether we could safely switch over to the new one or whether there was other stuff happening behind the scenes. So we found a couple of sneaky stored procedures in the old database. And until finally, after a certain amount of time, we got to the point where there was no divergence and we could safely switch over. So we learned some things here as well. One, do your due diligence on new technologies. We had to write our own SQL driver for Elixir, and that cost us 2 to 3 weeks worth of time. But at the same time, there's real benefits to doing that, because the team that was building it learned loads of interesting stuff about Elixir and Erlang. And we now have a great open source presence where we're maintaining the driver of one of the core kind of parts of that infrastructure. The second thing to talk about is bus factors. So yeah, a bus factor is, or maybe a lottery factor. If someone wins the lottery and they leave, where does that leave you? We had to move our new database into the analytics underlying data engine. Unfortunately, our head of analytics had left about 3 weeks before that. So we had to contract him back to do that because that whole thing was undocumented. So yeah, that cost us a bit as well. But mistakes are inevitable, but look for your bus factors. And then finally, when you're doing database migrations, you can get problems with sequential primary keys. So as you switch from the old to the new, the sequential key is coming down, and then you switch to the new, you've got to bump it down a bit so that you don't get a key conflict. And then as you come down, we had to switch back to the old one for a little bit of time. And then we switched to the new one, that we made a mistake, and we didn't get it right. And then we lost about 10 hours of registrations or something like that. But again, failure's inevitable. As long as you learn from it, it's fine. So the next day was Sunday again. Our little caterpillar ate through one nice green leaf. And after that, he felt much better. But he wasn't a little caterpillar anymore. He was a big, fat caterpillar. He built a little house called a cocoon around himself. And he stayed inside for more than 2 weeks. So this is a good point to talk about the fun stuff that you get to do at the end of a project like this. We got to delete 20,000 lines of code from the monolith. We got to build some extra fun stuff into the account service. Like there's a really great, we sent a couple of guys away to ElixirConf, and they came back and they built some really nice Swagger documentation and some process monitoring from within the app that you get from Erlang. And that was really, really great because it took that service from good to great, I would say. So he nibbled a hole in the end of the cocoon, he pushed his way out, and he was a beautiful butterfly. So that brings me to the end of the talk. I would like to thank Team T-Rex from Find My Past. They're the ones that did all this work. Without them, I wouldn't have anything to tell you. So a big thanks goes out to them. And that's it.
Thanks, Neil. Very great talk. Thank you. Where did we leave the microphone that can fly around? Ah, good. So, who has any questions? Do I have to say there's a book for you as well before you? Yeah, see, like immediately, there is no book. But guys, watch out. It's going to go this way. So.
Oh.
Right in the face. I was wondering, because you moved to Elixir, how are you managing having everyone support that next to? Because before it was in what language?
It was C#.net. Can you guys hear me? Yeah, it was C# and .net.
How did you manage the change in the operations department and for the developers?
Okay, so I guess what we've done is we gave everyone a learning hour, and we've encouraged them to do exercises on a site called Exercism. So they get an hour every day to practice coding. So we've asked people to learn Elixir and also JavaScript as we move towards new languages within the business, and they get an hour every day to do that. And once they kind of get through and get to a good level of competency in those languages, they can move off into other areas of learning if they want to. In terms of operating it, we have a kind of a standard. We have Greylog and Graphite and Isinga, and all of the new services that we build, they're scaffolded. And they're all hooked up to this kind of super structure, which helps you monitor and log them. So we've tried to shortcut it a bit like that.
All right. Who's the next one? Don't be shy. If you have questions about Erlang, now's the time. Over here. Heads up.
Oh, good throw.
There was a bit which touched a bit of a nightmare. You said you lost 10 hours of data. You just wrote it off, or you?
Well, we missed 10 hours of registrations. So because the primary keys reached a certain point, it can't insert. So those registrations just never happened.
Okay, and that was okay to the business. You couldn't refactor them through, reload them, or?
Well, the data's lost once you miss it, right?
This is the stuff of nightmares to me. I mean, I love the idea of going to these sorts of refactoring a monolith application, but I'm just thinking that would be the bit which would fill me with fear. That you wake up one day and you've lost like a day's worth of business.
Yeah.
I mean, I've had those sorts of scenarios, but someone always finds some incredibly ingenious way to reload it through a log or.
Yeah. Well, maybe. I mean, that could be something that we look at, is if we had a failure mode like that, could we log that out to our logging infrastructure and then recover those registrations?
Okay. That must have been a stressful.
That's something that we should definitely look at.
Okay. It must have been a stressful day, that.
Yeah.
Okay.
So we actually do have a book about database reliability engineering, which is incredibly relevant right now. So you do get to pick a lucky winner.
Okay.
I had a little book fairy come down with this, especially for this. So we need more questions, else we're not going to give it away. No, I can't even shame you into doing it? All right. Where do you need to go? All right. Okay, well, that's it then. You get to pick who wins this book.
I guess the database question wins
guy,
the database book.
Thank you, Neil.
Cheers.